Hello, it's Jason from STEMonline.com, where we help senior level high school and university students with mathematics and physics related courses. Sorry, I've been away for a while. I've been busy with other stuff. Now I'm back making videos again. Okay, so today we're going to look at a certain concept called taking the chain rule. Okay, this has to do with introductory calculus. So if you're either in uh, like one of your final math courses in high school, or even in university, they review this concept, first year university. Okay, so let's talk about finding the chain rule of a composite function. Okay, all right, so a composite function, first off, right, we'll go step by step here. It's good to define some formulas first before tackling a problem. Composite function is always in the form y is equal to, right, f of g, f of g of x, or in other words, you can write it like this, f parentheses g parentheses x, okay? In other words, what this is saying is g of x is a function, right? It's a function inside of the function f of x, okay? Right? So this is defined as a composite function. This is known as a composite function. Okay? Now, let's look at finding the derivative of a composite function, which is defined as the chain rule, right? So how do we do that? So if we take the derivative of our function here, okay, or y equals f of g of x, this now becomes, one second here, this now becomes y prime is equal to f prime of g of x, okay, times g prime of x, okay? This is the derivative formula of a composite function. Okay, so this is the chain rule formula. Chain rule formula. Okay, for any composite function. Okay, so let's look at a specific function that we're going to differentiate, or in other words, find the chain rule. Okay. So here's a question. If we have a function f of x, okay, f of x is equal to square root. Okay, let's make this over here. So square root of sine. Okay, sine. Let me make some erase this here. Sine of x squared. Okay. So let's say we want to differentiate this. Okay, so find the derivative. Find the derivative. F prime of x. Okay. All right, so the solution to this, okay, let's define each one of our variables here. I know that f of x, okay, so f of x is defined, let me see here. We already know what our f of x is. F of x is the entire function in this case. So that's equal to the square root of sine of x squared. Okay. Now, in order to find the derivative of this composite function, right, we need to take this whole function f of x, right, and decompose it into its elementary functions that make up f of x. That's what a composite function is. So we first need to figure out what that is. Okay, so I'm going to say let g of x. Okay, so let g of x. So let g of x equal to the square root of x. Okay, so my outer function is a function that's obviously it has to be dependent on x. Okay, but my outer function is the square root of x because the square root is outside. That's the outer function. Okay, so g of x is equal to the square root of x. I want my writing better. Okay, so g of x is equal to the square root of x. Okay, and let's define another function here. H of x will be our inner function. When I mean the inner function, this function inside that will be substituted into our g of x. Okay, so h of x is going to be equivalent to sine of x squared. Okay. Okay, so now we have the two elementary functions, g of x and h of x, and we're going to sandwich them together, if that makes sense. That was a pun intended. Okay, so g of x and h of x, okay? So let's define our function here. Okay, so we have g, right? So we have f of x. So let f of x equal to, okay, g as a function of h of x. That's what we're dealing with as our composite function. Okay, so I'm going to erase this for now because if we look at our formula here, right, we need to determine what our g prime is and our h prime, right? Because we're following this formula above, the chain rule formula. Sorry, chain rule formula that I drew earlier. Okay, and I'm putting an arrow at. The only difference is we've defined the variables differently, but it's the same thing. It doesn't matter what I call f, g, h, whatever. Okay. So let's determine, we have to determine g prime. In this case, that would be like our f prime from the original formula, right? That's the outer function. Okay, so we know that g of x, okay, g of x is also equivalent to x to the 1/2, okay? Right, I'm writing like this. I'm writing like this because it's more handy to write it this way, because then I can use a certain derivative formula that I know about, which has to do with the power rule, right? X to the nth power. Take the derivative of this, g prime of x is equal to n, which is 1/2, the exponent, times x to the power of n minus 1, 1/2 minus 1, okay? This now becomes g prime of x is equal to 1 over 2 x to the negative 1/2, okay? All right, so that's what we have here. So that's my g prime of x, okay? All right, so we have that. And this can be written, preferably we want to have positive roots here, so g of x is equal, g prime of x is equal to 1 all over 2 square root of x, okay? So we figured out what our g prime is. Okay, next thing is to look at the h of x. H of x was sine of x squared. Okay, so h prime of x, right, is equal to cosine, right, of x squared. Chain rule the inside. This is the inner function. The outer function was cos. The inner function is x squared. So chain rule this, taking the derivative of the inner function and multiplying it will be by 2x. Okay, therefore I get h prime of x is equal to 2x times cosine. Okay, 2x times the cosine of x squared. Okay, so that's h prime of x. Okay, so now I have g prime and h prime. Okay, now we can find the derivative of our composite function, right? So I can figure out what my f prime is. F prime will be written like this, because it's f prime of x, is equal to g prime of h of x, bracket, times, right, so it's a little bit, make your 8 times h prime of x, okay? So substituting this all in, I know what, oh yes, almost forgot, we need our h of x here. We need to substitute what h of x is into our g prime, okay? Before doing this formula. So we now need to substitute in. Okay, guess I'm gonna write something here. Probably gonna make some room. Okay, so since right, so since h of x was equal to sine of x squared, right? Since h of x is equal to sine of x squared, substitute into g prime, right? So g prime, right? G prime of h of x. That's what we're finding, or in this case, g prime of sine of x squared. So that means that every x is replaced with a sine of x squared function in the g prime. Okay, so this becomes 1 divided by 2 times the square root of sine of x squared. Okay, so we have that. Now we can use, so thus we can now, I'm just going to connect this over here, we're continuing. Okay, so continue over here. Thus we can now say that we have, let me see here, we have g prime, right? So f prime of x follows this formula, g prime of h of x times h prime of x. Okay. Okay, so now we have f prime of x is equal to g prime. Let me just label everything here. So it's going to be g prime of sine of x squared. Sine of x squared times the h prime, right? I know my h prime was 2x cosine of x squared. Okay, 2x cosine x squared. Okay, and we know g prime of sine of x squared was 1 all over 2 times the square root of sine x squared times our h prime of x, which we found to be 2x times cosine of x squared. Okay, the 2's get divided out. I'm left with x times cosine of x squared, all divided by the square root of sine of x squared. Okay, and that is my f prime of x. Okay, and that is the solution to this problem. Okay, so I hope you enjoyed this video. Hopefully it helped you guys conceptualize how to differentiate composite functions. The way you do that is to use the chain rule, right? I hope you enjoyed this video. I know it's a concept that for students who take calculus first time quite often get confused. That's why I want to uh, do this video. Okay. Hope you liked it. Like and subscribe, and I'll see you in the next video. Have a great day.